So linear functions, we get started by talking about slope. Slope, you guys heard of slope before, right? Slope, we formally say the change in y divided by the change in x. You probably know this as rise over what? Rise over 1. All right, so this is your slope formula. We've seen it before. A lot of times you will see your slope represented by this variable m. And so if you want to find the slope, between 2 points, this is the formula you will use. All right, let's do that. Feel free to kind of work ahead if you recall this and you feel good about it. So this is our point 1 and this is our point 2. Let's find the slope of the line passing through this pair of points. So we're going to use this formula, y2 minus y1 over x2 minus x1. So from point 1 we get our x1 and our y1, and then from point 2 we get our x2 and our y2. So help me find this slope. What's y2? 4 minus what? -1 divided by, what comes first? -2 minus what? -3. Good job. What's the top come out to equal? 4 minus -1? 5. Yep, so when I subtract a negative number, I'm going to add it. So 5 divided by, what's the bottom come out to be? Yep, +1. Oh, I can reduce this. What's this? 5. So slope between these 2 points is 5. All right, everybody okay? Okay, so we can use our slope to make equations, and we can do more kind of real life situations using this. Let's just work on finding an equation that goes through a point and a slope. So we got this point slope form. Like I say, you should have seen it before. This will help you set up an equation based on some information you're given. We do need 2 things to be able to do this. We need a point and we need a slope. My slope will be m, and then your point will give you y1 and x1. All right, so as long as you have those 2 things, you'll be able to make an equation. So it says write an equation in point slope form with the line with the slope of 4 that passes through the point -1, 3. All right, so we'll do that. So when you use this equation, you don't replace this y or this x, you only replace the ones with the subscript. So I will start this off by y minus, what's y1? 3. And this equals, what's my slope? 4 parentheses. I don't replace this x, but I do replace x1 with what? -1. Can I go ahead and just do +1? And just stop me if something's not looking right or got a question or something. Okay, this is my point slope form. I've got a point, and I got a slope. If you want to try to graph this or maybe like work with this equation, it doesn't look very nice, so we'll solve this equation for y, and what we'll be doing is getting into slope-intercept form, which you're probably pretty familiar like looking at and graphing. So let's solve this equation for y. Help me out. What would you do to get you started? Distribute the 4. Sounds good to me. So I will do y minus 3 equals 4 times x plus what? Plus 4. What would you do next? Add 3. So over here that would give me 7. All right, and we solved it for y. So what we did was we put it into slope-intercept form. This is nice because you can see your slope, 4, and you can see the y-intercept, which is plus 7. It'd be very easy to graph this now that we got it in this form. Got any questions? All right, let's keep rocking. So as we look at example 3 on the right, we want to make an equation, okay, that lets me know I'm going to use the point slope form again, and it says the line passing through the 2 points. I want to make an equation. I need a point and a slope. Did it give me a slope? It didn't give me one. What am I going to do? How am I going to find a slope? Can I make an equation since I don't have a slope? Yeah, I'm going to do rise over run to find the slope. It's kind of like what we did in 1. Once we find the slope, we can then use a point and make an equation. So let's find the slope. Rise over run. Y2. 6 minus what? Can I go ahead and do 6 plus 3? All right. Over negative 2 minus 4. What's the top result? 9. What's the bottom result?
Negative 6.
Can I reduce this? What's it reduced to? 3 over negative 2. Good job. So we got a slope. 3 over 2. Now I put a negative out in front. All right, now I need a point. Which point should I use? Or doesn't matter? Doesn't matter. Doesn't matter. If you, I don't know, get caught up on, which point do I use? Just make it a habit of always using the first one. Like I say, I'm lazy a lot of times, so if one of these looks easier with smaller numbers, I'll probably use that one. But you can use 0.1 or 0.2. Doesn't matter. So I'll use 0.1. And you don't have to write it. I'm going to just write it so we can see all our parts and what we're about to do. So I got a point and I got a slope. I can use the point slope form or formula to make an equation. So let's do that. I got y minus what? y1. What's y1 based on this point? Negative 3. So y plus 3?
Yes.
Equals, what was my slope?
3 over 2.
Yep, 3 over 2. Just need a negative in there. You can put it on the top, you can put it on the bottom, you can put it out in front. Just make sure it's there. Parentheses, x minus 4. All right, that's my point slope form. Let's make it look a little nicer and put it in slope-intercept form. What would you do first? Distribute. And we get y plus 3 equals negative 3 over 2x. And then negative 3 over 2 times negative 4. What's that result going to be? 6 is good. I don't have a lot of space, so I'll write it up here real quick. But I would get negative 3 over 2 times negative 4. And if it helps to think about it, it's like negative 4 over 1. So negative 3 times negative 4, 12 over 2 equals 6. Okay, everybody okay with that? I probably would have said, I can cancel those, 1 and negative 2, 6. Either way you go, you get 6. So plus 6. And then I subtract 3 from both sides. And now I've got it in slope-intercept form. All right, anybody got any questions? Do y'all want me to do this other one below and to the left? I don't mind. But if y'all feel like, I got it, we can just keep moving. Does anybody want me to do this one? I don't mind. All right, I figured. How we feel about graphing these? Pretty good? Not good at all? All right, so I know some of us are in different spots. Some of us gonna say, ooh, I could do this in my sleep. Some of us might need some sleep after we work through this, but let's do it. All right, so you do have like a little steps to graphing these. When you go back and look on your own, and if you need to try to figure out like, I forgot what we did, this is over here. I won't just read those to you. We'll actually do it. So those of you who feel comfortable, like, let's get started with graphing this function. How do you start graphing this function? What do you do first?
Put a point on 2.
Put a point on 2. Yep, that's exactly where I would start. This 2 is what? It is positive, but it's on this line. What does this line represent? The y-axis. So any point on this line would be a y-intercept, right? So this point that you see right here, this 2, whenever it's in slope-intercept form, it would be b over here. That's always like where you start. This is your y-intercept. Y-intercept is on the y-axis, so you just always go to that point. It's positive 2, so I go up 2, and just like that, I get my first point for my graph. I only need one more point, and then I got a ruler. Some of y'all can probably draw straighter lines than me, but I got a ruler. If I get 2 points, I can draw this graph pretty simply. How do I move from this point? What do I look at?
Go down 3
over 2.
Down 3 over 2. Perfect. You got that from the slope, right? So that's the number that's in front of x. Negative 3 over 2. So that tells me how to move from this point. I go down 1, 2, 3, and then I go positively right 1, 2, and I get my second point here. And you could have even went backwards. Sometimes, like if your point is up here almost off the graph, or like down here almost off the graph, you'll want to go backwards. So you could have also did 3 and negative 2, as long as like one of the values is negative. So even if I wanted to go the other way, I could go up 1, 2, 1, 2, 3, and then over 1, 2, and everything is still kind of in line. Draw through the points. Just like that, I got my linear graph. So you get it in y-intercept, slope-intercept form. Just find the y-intercept, use the slope to get to the next point. 2 points is all you need, and you're good to go. We got any questions? All right, so if I want to do the one on the right, what's my slope? Can I see my slope right now? I can't. It's in standard form. I want it to look like this because it's easier for me to graph. So let's make it look like this. What would I solve for? Y. Where would I need to move first? 3x. Well, I subtract it, add it, divide it, subtract it. 4y equals negative 3x plus 4. I divide both sides by 4. And I get y equals. Should I write this as a decimal? No, 0.75. Maybe if you were like getting information out from it, but to graph it, leave this as a fraction. Because remember, this is your rise overrun. And then 4 divided by 4 is 1. All right, what's my y-intercept?
1.
Yep. 1. What's my slope?
Negative 3 over 4.
Negative 3 over 4. We're ready to graph. Where do I start? At the 1. How do I move?
Down 3, over 4.
Yep. By over, you mean left 4?
Yes. No, survive.
Yes, I knew I could get somebody. 1, 2, 3. 1, 2, 3, 4. And you could have made this 4 negative. You could have, and you don't have to write this, but just some people get caught up on this. Could have also did this. If I go back to this point, I would go up 1, 2, 3. Then I would go left 1, 2, 3, 4. And everything is still in line. All right, we're good? All right. All right, just some graphs that kind of trip people up sometimes. To graph x equals 2, is that this way
No.
or this way? This way? X equals 2? X equals 2 is right here, right? So you're telling me I would do it like this?
No. You would do that.
I would do it like this. Because no matter what y is, x will always be 2. So with these x equals something, these are your vertical graphs. Or a vertical line graph. Just straight up and down. Well then by default, y equals negative 2 would be a horizontal graph, right? So I would just go to that value, negative 2, and no matter what x is, y is always negative 2. And with these, you just go to the value. If it was x equals negative 3, you go to negative 3, vertical graph. X equals 0, go to 0, vertical graph. Y equals, go to that point, and then graph it. What is the slope of this blue line? Am I rising? I am running though. What is like my change? Do I have a change? Like going up or going down? I don't. So what would the slope be? 0. It's just a flat piece of ground. My slope is 0. Slope is 0. Now for x equals 2, I'm rising, but I'm not running, right? How quickly am I rising or falling? Can you tell? No, nobody, you don't know because it's undefined. It's undefined. Now, reason being is, for this one, the blue one, and we'll turn over and look at the slope, man. So you got uphill, you got downhill. This is positive slope, this is negative slope. When you have like 0 over some number, your result comes out to equal 0 for your slope. That's this case. When you flip it and you get some number divided by 0, well, you can't do that. Your slope is undefined. Okay, so just make sure you understand the difference between the two. Does that make sense? This case is where you divide by 0, your slope is undefined there. This one, your slope is just 0 because you're not going up or down. You're just staying flat. All right, so just watch out for the differences between those two. All right, so let's, we can do this one to the right. So last form is normally 3 forms that you'll get these linear functions in. Standard form. Standard form, you can see it in 2 different ways depending on like what book you're looking at or whatever, but one example might be like your x's and your y's are on the left together. That could be like a version of standard form, and I'm just making these up. You also might see something like you have below where like maybe x plus 2y minus 2 equals 0. So everything's on the left side. You'll see that sometimes too. But this is standard form where primarily your x's and your y's are over on the left side. All right, so sometimes when it's like this and like maybe your ACT, it's easier to graph just using the intercepts. And we'll do that to finish up the graphing. But this is standard form. When you see standard form, this is what it's talking about. So we got standard form over here. We want to find the slope and the y-intercept. Can I look at this and see the slope right now? Not yet, because it's not in the right form. What form do we want this to be in to be able to see the slope and the y-intercept? Okay, so we need to solve this for what?
Yeah, X by itself.
X or y?
Y.
Yeah.
Yeah.
Get y by itself. So let's do that. What would you move first?
X.
X, okay, by subtracting 3x from each side. Let's see, I'll rewrite it. Might be hard to see. So I will subtract 3x from both sides. And then you add what to both sides?
4.
4. And then finally you divide by 2. 4 divided by 2 is 2. And let me know if we didn't make it here. I know I didn't show all my work, and let me know if something doesn't look right or makes sense. What's my slope?
2.
What's my y-intercept? 2. So my slope can't be 2. Yep, -3/2. Remember, slope is always attached to x, because that tells you how x will change. Another way, what's the value of x for your y-intercept? Because your y-intercept is on the y-axis, right? What's the value of x on the y-axis? 0. So if I let x equal 0, that's why this is a y-intercept. When x is 0, y is 2. So we don't have to plug it in like we did the other day. We just look at this number because this will become 0. So your y-intercept is always the number by itself. Sorry, it's kind of messy, but my y-intercept is at y equals 2. All right, so let's graph using the intercepts, which some people like, and then we'll look at some average rate of change. All right, so we're going to graph using the intercepts. Now, if you see this and you're like working a problem or like doing a quiz or something, at the end of the day, just graph. Don't like skip over this one. If you're good graphing how we graphed over here, just graph, just get it graphed. Like don't get caught up on, oh, I have to use the intercepts. Just get it graphed at the end of the day. But let's graph using the intercepts. Let's first use the y-intercept. Let's find the y-intercept. So the x-intercept is on the x-axis, right? What's the value of y on the x-axis? 0. So we're going to let y equal 0 to find our y-intercept. And we're going to go ahead and move this 6 over because it'll just make things go a little quicker. So I'm going to add 6 to both sides, and I get 4x minus 3y equals positive 6. All I did was add 6 to both sides. So now we'll use this. We're going to let y equal 0, and we'll get the x-intercept. So I get 4x minus 3 times 0 equals 6. 3 times 0 is 0, right? So I got 4x equals 6. X equals what? 6 over 4, can that be reduced? Yep, it's got a common multiple of 2. That reduces to what? 3, 2. 3, 2 is in between 1 and 2, right? So that's where I'm going to put my x-intercept. So I got 1, I got 2. I'll put it right in between them. That's my x-intercept. Just need one more point and I should be able to graph this line. Let's do the y-intercept. What do you think we're going to let x equal? 0. Because we're on the y-axis. Right, so I won't even write this time because that's going to be 0, right? 4 times 0, 0. I'm just going to go straight to, I'll write it so it don't look like magic, but I'll go straight to here. And honestly, you don't need that. So then I just divide both sides by what? -3, and I get y equals -2. It's my y-intercept. 1, 2. Got my 2 points. Struggle to draw straight lines, so I got a ruler. And if you start doing this and you want a ruler, I got a bunch over there. That's what I got. All right, any questions? We feel like masters of graphing linear equations. Probably already felt like that before you came in here, but should be feeling good now. All right, let's finish up looking at average rate of change. All right, so even when we're getting these like real world situations or problems, at the end of the day, slope is your rate of change. So even though these become like real numbers and stuff, at the end of the day, you're still doing slope. y2 minus y1 over x2 minus x1. That's your rate of change. So let's do that. It says we have, the graph gives the median age. What's median? What's median mean? Middle, average. So the average age of the U.S. population in the indicated year. The data is displayed as a scatter plot. Scatter plot is just a graph that has different data points scattered throughout it. With 2 points on the line indicated. So scatter plot would just have these points here. What we did was what some people call a line of best fit, just to kind of represent what's happening with the scatter points. All right, it says find the equation of the line in order to make predictions of the U.S. population in the future. We want to predict what the median age will be in the year 2030. All right, so let's make sense of this scatter plot that we see. Over here you have the years after 1970. This would be like your X values. And then over here going up would be the median age or the average age, which is like your Y value. So let's say this point 1030. What does that mean? 1030. What's this 10 mean? 1980. So 10 years after 1970. What's this 30 mean? The average age. So in 1980, the average age was 30 for a citizen of the U.S. in the USA. What about this 30? What year is 30? 2000, 30 years later. What was the average age? 35.3. Does that make sense? What's happening over time? It's increasing. Is that good or bad? Some people say, it should be good. You live longer, right? So the average age goes up. Maybe like technology and just people are learning new things about, like, I don't know, staying healthy and maybe finding medicine and cures for things. So people are living longer. That's great news for somebody who's old like myself. Hopefully it'll keep rising. I'm not at the median age yet. Hopefully that continues to happen. Okay? So we want to make an equation to where we can get out, like make future predictions. So 2030 isn't on this map, but what if you wanted to see in 2050? What would the average age be? Or we can maybe go back in the past. What about in 1930? Based on this information, what would the average age be? We're going to make an equation that represents that. So first thing we need to figure out is, what is this average rate of change? How are we going to do that? So if we go back and look before, we found the slope, or the average rate of change between 2 points, by using what? The slope formula, right? Do I have 2 points here? Can I use the slope formula to find the change? Sure. Let's use the highlighted points here. And let's find out what this yearly rate of change is. Because that's all slope is. So either one of these can be your 0.1. I'll let this one, because it came first, be my 0.1. And this one be my 0.2. Even if you swap them, you should get the same thing, as long as you line everything up accordingly. So my Y2 would be 35.3 minus what? 30. That's my change in Y. On the bottom, what would I start with? 30 minus 10. Let's see, don't need a calculator yet. What's the top come out to equal?
5.3.
Yep, good job. 5.3 over what? 20. So in 20 years, the average median age increased by 5.3. When I divide this, it'll give me a yearly rate of change, because you divide that 5.3 by 20 years. I don't have a calculator close, but done this so many times, I just remember it. Yeah, that's right. Good job. 0.265. That's what I got too, mentally. I did some mental math and I got that. All right, so each year, the median age of the U.S. population is increasing by 0.265. Now, that's not a big increase, but it is an increase. And especially over time, you can see that median age get up, which is fantastic news for myself. Okay, so we want to make an equation. Do we have a slope now? Do we have a point? So you're telling me we got a point and a slope. What formula are we going to use?
Like slope form.
Man, you connected the dots. That's amazing. Point, slope form. We got a point and we got a slope. Let's use point, slope form to make an equation. All right, so just to be clear, we're using our point, slope form, because we have those two things, we can make an equation. So I got y minus y1. 0.1 doesn't have the decimal, so I might use 0.1. So it'll be y minus 30 equals m, my slope, which we found, 0.265, x minus what?
5.3.
From 0.1? The x value is 10, right?
Oh, yeah.
So just like we've been doing, let's distribute this 0.265. 0.265 times x, and then 0.265 times negative 10. Anybody mental math?
26.5.
How many zeros do we have?
1.
Close. So how many?
2.
Yeah, just one spot. We just moved the decimal one spot to the right. Think, if it was times 1, it would be itself. If it was times 10, 1 spot. Times 100, 2 spots. So we just moved the decimal 1 spot. So 2.65. Then I add what to both sides? 30. All right, so 27 and some change, right? Because if it was 30 minus 3, it would be 27, but it's not quite 3. 27.35. All right, so this would be my slope, and this would be my y-intercept if I was graphing this, right? Is this pretty accurate with like the y-intercept here? Yeah, a little over 27. That makes sense. I got my average rate of change each year. That makes sense. So now I can get out information. We wanted to do the year what? 2030? So I put 2030 in here?
60.
60, yeah, because I'm doing years after 1970. 2030 is 60 years after 1970. So I'm going to let x equal 60. And I'm going to make a little note so it doesn't look like magic. If you need to write it, write it. If not, it's all good. So x equals 60 years, not at, but after. $1970. So we can use our calculator for that. Let me write the setup. I will do 0.265 times 60 plus 27.35. Anybody put this in yet?
I got 43.25.
That is it. So what does this mean? The average age in the year 2030. So just to summarize, the average age will be 43.25 in 2030. So you could use this to find 2040, 2045, 2047. You just plug in the appropriate year, you get out the median age. Now at some point, like, it probably won't make sense. I mean, if you did the year 3030, you might get like 80 or something. I don't know if that's going to happen, but you never know. I don't think the median age will be like 80, but I don't know. Never know. All right, any questions? Okay, let's do one more rate of change. There's a little bit of room I have. All right, so last one. So it says, given a function defined by f of x, we want to determine the average rate of change as we go from x1 to x2. This is a more like calculus type of way of doing average rate of change. So we want to find the slope, which is what the average rate of change is. In order to find the slope, I would need 2 points, right? I could find the slope between 2 points. I'm given some x values. Am I given y values? I am not. So I might feel like I can't do the slope, but we have a function to get this out. So I know that x is normally the independent variable. I can get out y by substituting these values into the function. What I mean is, our slope function will look more like this up here, where we're given some values for x, and in order to get the y value, we have to evaluate the function to get out the y value. So we got to do a little bit more work to get the y value. But in more mathy type of situations, when you have some kind of graph that's a curve, and we want to find the slope between any two given points, which is my x1 and my x2, we're really just looking at a straight line that goes right between these 2 points. This will be my slope that I'm looking for. Even though my graph may be doing all this, I'm just going between these 2 points. What was that average? All right. right? So this blue line can be any function. That's what this f of x is. So this can change. We got to get out y. So when we set it up, we're going to kind of set it up like this. So let's try to get it set up. So we're still finding the slope. I'll use m. And let's do the bottom first because that's pretty straightforward. It's just x2 minus x1. What is x2? 0. What is x1? So minus -2. Go ahead and write plus if you want to. So nothing there, it's just x2 minus x1. Now to get my function, I'm going to put these values into my function. So my y2 will be f of 0, which is the x2 value. To get y1, I'll do f of what? -2. Now I'm going to put these values into my function, and I'll get out what the y's should be. Does that kind of make sense? All right, so let's see if we can fit that. So we'll just add these two, and this denominator will just be 0 plus 2, which is 2. Let's do f of 0. So just to be clear, I'm going to this function, and I'm going to put 0 in there. So I get 0 squared minus 1. That's f of 0 minus f of -2. -2 squared minus 1. Everybody okay? And some people would like to do this on the side. So you might come over here and do f of 0 and then come back and write what it came out to equal. And then you might go to the side and do f of -2, and then you'll come back over. Some people like to do it like that too. And then we said the denominator is what, 2? All right, what's 0 squared? What's -2 squared? 4 minus 1 is 3. So 0 minus 3 on the top. Not 0, it should be -1, right? Because we got, let me just write it out. Getting ahead of myself. So we got 0 minus 1. 0 minus 1. And then over here we got 4 minus 1. Okay, everybody okay? Here I got -1 minus what? Divided by 2. The top comes out to equal -4 divided by 2, which is -2. So my average rate of change between these 2 points would be -2. Just so we see it for this specific one, this would be like a little parabola. It's transformed by dropping 1. We'll do that eventually. And x1 was -2. x2 was 0. So we had like these 2 points. And we just found that slope. So it makes sense that it's negative because my slope is downhill between these 2 points. That's what we just found. Right, don't worry about that. You guys have any questions with this process? All right, you guys have any questions about anything?